What are the best technologies to create vegan products, materials, and energy? Creating high-quality vegan products involves leveraging innovative technologies across food science, biotechnology, and sustainable manufacturing. Here are some of the best technologies used in developing vegan products. Plant-based protein extraction. Hydrocolloid extraction, for creating textures similar to meat, dairy, or eggs, using ingredients like pea protein, soy protein, or mung beans. Wet and dry processing, used to isolate proteins from raw materials like lentils, chickpeas, or oats. Micronization, reduces particle size for improved solubility and texture in products. Fermentation technology. Precision fermentation produces specific animal-free proteins such as casein or whey used in vegan cheese or milk alternatives. Traditional fermentation enhances flavors, textures, and nutritional profiles in products like tempeh, kombucha, and vegan yogurt. 3D printing creates intricate textures and structures for plant-based meats, mimicking the fibers of muscle tissue for products like steak or chicken breast. Cellular agriculture. Cultured ingredients develops animal-free fats and collagen to improve the mouthfeel and authenticity of vegan alternatives. Enzymatic processes used to replicate the functionality of animal-derived enzymes in creating flavors and textures for vegan cheese, butter, or egg alternatives. Flavor science. Natural flavor compounds mimics the umami and savory notes of meat or dairy using plant-derived or synthesized ingredients. Encapsulation technology preserves and delivers flavors in vegan products, enhancing the overall taste experience. Lipid structuring. Oleogelation converts liquid plant oils into semi-solid fats, mimicking the texture of animal fats in baked goods and plant-based meats. Thermal and high-pressure processing. Extrusion cooking creates meat-like textures from plant proteins. High-pressure processing, HPP, enhances the safety and shelf life of fresh vegan products like juices and ready-to-eat meals. Algae-based technology. Algae are used for sustainable sources of omega-3 fatty acids, proteins, and natural colorants. Biotechnology for nutritional enrichment. Gene editing enhances the nutritional profile of plant-based ingredients, such as increasing vitamin or protein content. Fortification adds essential nutrients like B12, iron, or calcium to vegan products to match or surpass the nutritional profile of animal-based counterparts. Sustainable packaging. Biodegradable and edible packaging complements the eco-friendly ethos of vegan products, using materials derived from plants like seaweed or cornstarch. AI and machine learning optimizes formulations, predicts consumer preferences, and accelerates product development cycles for vegan innovations. Creating high-quality vegan products involves adopting advanced technologies across food science, biotechnology, and sustainable manufacturing. These technologies enable the development of products that replicate the taste, texture, and nutritional benefits of animal-based foods while adhering to plant-based principles. Plant-based protein extraction. Plant-based protein extraction is a foundational technology in vegan product development. Techniques such as hydrocolloid extraction are used to isolate proteins from plant sources like soy, peas, and mung beans, enabling the creation of textures that mimic meat, dairy, or eggs. Wet and dry processing methods further refine these proteins, while micronization reduces particle size for improved solubility and texture in foods like vegan milk or protein powders. Fermentation technology. Fermentation plays a crucial role in enhancing the flavor, texture, and nutritional profile of vegan products. Precision fermentation is a cutting-edge approach that uses microorganisms to produce specific animal-free proteins, such as casein or whey, for use in vegan cheese or milk alternatives. Traditional fermentation methods are also widely used to create products like tempeh, kombucha, and plant-based yogurts. 3D printing. 3D printing technology is revolutionizing the production of plant-based meats by creating intricate textures and structures that mimic the fibers of animal muscle tissue. This technology is particularly effective for producing products like vegan steak or chicken breast, where texture and appearance are critical. Cellular agriculture. Cellular agriculture focuses on developing cultured ingredients that enhance vegan products. For example, it enables the production of animal-free fats and collagen, which improve the mouthfeel and authenticity of plant-based alternatives. These innovations are particularly valuable in replicating the sensory qualities of animal-derived products. Enzymatic processes. Enzymatic processes are used to replicate the functionality of animal-derived enzymes in vegan food production. For instance, they are crucial for creating the characteristic flavors and textures of vegan cheese, butter, or egg substitutes. Flavor science. Flavor science plays a vital role in making vegan products appealing. Scientists use natural flavor compounds to mimic the savory and umami notes of meat or dairy. Encapsulation technology is often employed to preserve and deliver these flavors, ensuring a satisfying taste experience for consumers. Lipid structuring. Lipid structuring technologies, such as oleogelation, transform liquid plant oils into semi-solid fats. This technique is essential for replicating the texture and functionality of animal fats in products like baked goods, plant-based meats, and spreads. Thermal and high-pressure processing. Thermal and high-pressure processing techniques are used to enhance the texture and shelf life of vegan products. Extrusion cooking, for example, is a widely used method for creating meat-like textures from plant proteins. High-pressure processing, HPP, ensures the safety and freshness of ready-to-eat vegan meals and beverages. Algae-based technology. Algae-based technology is increasingly used in vegan product development due to its sustainability and nutritional benefits. Algae serve as a rich source of omega-3 fatty acids, proteins, and natural colorants, making them an ideal ingredient for vegan supplements and food products. Biotechnology for nutritional enrichment. Biotechnology is employed to enhance the nutritional profile of vegan ingredients. Gene editing techniques can improve the protein or vitamin content of plant-based raw materials. Additionally, fortification is used to add essential nutrients like vitamin B12, iron, and calcium to vegan products, ensuring they meet or exceed the nutritional value of their animal-based counterparts. Sustainable packaging. Sustainable packaging technologies align with the eco-conscious ethos of vegan products. Biodegradable and edible packaging materials derived from plants, such as seaweed or cornstarch, are increasingly being used to reduce environmental impact. AI and machine learning. Artificial intelligence, AI, and machine learning are powerful tools in the development of vegan products. These technologies optimize formulations, predict consumer preferences, and accelerate the product development process, enabling companies to create innovative and appealing vegan offerings more efficiently. These technologies collectively address the challenges of taste, texture, nutrition, and sustainability in vegan product development. By leveraging these advancements, companies can produce high-quality vegan products that meet the growing demand for ethical and sustainable food options. The most advanced technologies for creating vegan and plant-based products, materials, energy, and essential goods focus on replacing animal-derived resources with sustainable, cruelty-free, and environmentally friendly alternatives. These technologies are transforming food, textiles, fuels, chemicals, packaging, construction, and more. Food technologies. Precision fermentation uses microbes like yeast or fungi, programmed with genetic instructions to produce specific proteins, e.g., casein, whey, collagen, without animals. Enables production of vegan milk, cheese, eggs, and meat proteins. Key players: Perfect Day, dairy, The Every Company eggs, Gelter collagen. Cell-free and molecular farming. Plants or microbes produce specific compounds like animal-free egg whites, enzymes, or fats, more scalable and cheaper than cellular agriculture. Example: Tiamat Sciences grows animal proteins using plants and bioreactors. Cultivated fat and flavor enhancers. Plant-based or microbe-grown fats that replicate the mouthfeel and cooking performance of animal fats. Example: cultured oil by Zero Acre Farms made from fermentation. Plant-based texturizing technologies. High-moisture extrusion and shear cell technology create fibrous textures similar to meat using soy, peas, oats, or other crops. Examples: meaty, mycelium-based meat, redefined meat, 3D printed meat. Advanced materials technologies. Mycelium-based materials. Grows the root structure of fungi into durable materials used for leather, foam, packaging, or building panels. Applications: fashion, bags, shoes, packaging, furniture. Examples: MycoWorks, Ecovative, Bolt Threads, Milo Leather. Bioplastics from plants and algae. Made from starches, cellulose, or oils from plants like corn, sugarcane, seaweed, or algae. Fully biodegradable and petroleum-free. Example: Notpla, seaweed plastic, Lalaware, edible packaging. Natural fiber composites. Combine hemp, flax, bamboo, or kenaf with biodegradable resins to replace wood, fiberglass, or plastic in construction and manufacturing. Used in automotive parts, furniture, and buildings. Bacterial cellulose and fruit-based leathers. Microbes or fruits like apples, mangoes, or grapes are used to create flexible, durable, cruelty-free leather alternatives. Examples: Pinatex, pineapple leather, fruit leather, Vegia, grape leather. Renewable vegan energy. Bioenergy from plant and food waste. Anaerobic digestion turns vegan waste into biogas. Gasification and pyrolysis turn biomass into syngas or bio-oil for heat, electricity, and biofuels. Algae-based biofuels. Fast-growing algae converts sunlight and CO2 into oils for biodiesel and jet fuel without using arable land. Potentially carbon negative with the right setup. Solar and organic photovoltaics. Bio-based solar panels made from organic materials like conductive polymers, some derived from plant compounds. Lightweight, flexible, and more sustainable than traditional silicon panels. Vegan and plant-based industrial inputs. Green chemistry and biocatalysis. Replace petroleum-based industrial chemicals with compounds made by microbes or enzymes using plant feedstocks. Used in detergents, dyes, pharmaceuticals, plastics, and solvents. Plant-based adhesives and resins. Replace toxic synthetic glues and epoxies with lignin, soy protein, or sugar-based bioresins. Used in furniture, flooring, and construction. Microbial and plant-based textile dyes. Natural dyes grown by bacteria or extracted from plants reduce the environmental impact of textile dyeing. Vegan construction and design technologies. Hempcrete and biobricks. Made from hemp huds and lime, or from bacteria and agricultural waste. Carbon sequestering, durable, and mold-resistant. Mycelium insulation and acoustic panels. Grown into shapes that insulate buildings or provide soundproofing. Fire-resistant and compostable. Wood-like materials from plants and fungi. Compressed plant fibers and engineered wood alternatives made without animal-based binders or toxic resins. Tools enabling vegan innovation. Synthetic biology. Programs DNA and microbes or plants to produce animal-identical compounds without animal use. Enables production of meat, milk, and eggs from fungi or bacteria. AI-powered food and product design. Machine learning models optimize flavor, texture, and nutrition using plant ingredients. Example: Notco uses AI Giuseppe to create vegan versions of mayo, milk, meat. 3D food printing. Layer plant-based ingredients into structured foods, like steak, salmon, using precise digital designs. Example: Revo Foods, redefine meat. Circular and regenerative systems for vegan production. Closed-loop urban farming. Aquaponics, hydroponics, and vertical farms produce high yields of vegan crops in small, efficient urban spaces, often powered by solar or wind and using recycled water. Waste valorization turns food waste into valuable materials, biofertilizers, bioplastics, enzymes, or even textiles. Example: orange peels into fabric, potato starch into bioplastic. Fungal and algae biorefineries. Use fungi or algae to produce multiple outputs: protein, fats, fiber, pigments from low-cost vegan feedstocks. Enabling infrastructure and platforms. Blockchain for ethical supply chains. Verifies vegan, cruelty-free, and sustainable sourcing across global supply chains. Vegan certification via IoT and AI. Monitors ingredient integrity from farm to shelf to ensure no animal inputs or testing. Open-source platforms for formulation. Allow startups and communities to share vegan food or material recipes and biomanufacturing methods. Creating a sustainable future based on vegan and plant-based systems relies heavily on the development and deployment of advanced technologies across every major sector. These technologies enable the replacement of animal-derived resources with environmentally friendly, cruelty-free, and regenerative alternatives. Advanced technologies for vegan and plant-based foods. Precision fermentation. Precision fermentation is a cutting-edge biotechnology that uses genetically engineered microbes, such as yeast or fungi, to produce animal-identical proteins, enzymes, and fats without using any animals. For instance, companies like Perfect Day produce vegan dairy proteins, and every company creates egg proteins using fermentation. These ingredients are then used to make vegan cheeses, milks, eggs, and meats that closely mimic their animal-based counterparts. Molecular and cell-free farming. This technique allows plants or microorganisms to produce specific animal-free compounds, such as collagen, gelatin, or egg white proteins. Unlike cellular agriculture, which grows whole animal tissues, molecular farming focuses on growing just the desired molecules in a controlled environment, reducing costs and accelerating scalability. High-moisture extrusion and shear cell technology. These mechanical processes transform plant proteins, from soy, peas, wheat, etc., into fibrous textures that closely resemble meat. By aligning plant proteins during cooking and pressure treatment, these technologies make plant-based meat products more realistic in texture and bite. Fungal and mycelium-based proteins. Mycelium, the root structure of fungi, is a rapidly emerging source of high-protein, meat-like foods. Companies like Meaty and Corn use fermentation to grow mycelium into structured products that mimic the texture of steak or chicken, while also being nutritious and low-impact. 3D printing of plant-based foods. Advanced 3D printers can layer plant-based ingredients into complex structures that resemble whole cuts of meat or fish, such as steak or salmon. This allows for creative design and customization in vegan food production. Technologies for plant-based and vegan materials. Mycelium-based materials. Mycelium can also be used to create sustainable alternatives to leather, foam, packaging, and even construction materials. Grown into molds, it forms strong, lightweight, and biodegradable structures. Companies like MycoWorks and Ecovative are leaders in this space, producing fungal leather and packaging materials. Plant-based leathers. Natural leather alternatives can be made from agricultural byproducts like pineapple leaves, Pinatex, apple peels, grape skins, Vegia, or cactus deserto. These materials are tanned and processed without harmful chemicals and offer durable, flexible options for use in fashion, furniture, and automotive interiors. Bioplastics and algae-based packaging. Bioplastics derived from corn starch, sugarcane, seaweed, or algae can replace petroleum-based plastics. These materials are biodegradable and can be composted, significantly reducing plastic pollution. Seaweed-based packaging companies like Napla are leading this movement. Natural fiber composites. Hemp, flax, bamboo, and other plant fibers are being combined with biodegradable resins to create eco-friendly materials used in automotive panels, electronics, construction, and furniture. These composites are lightweight, strong, and renewable. Renewable and vegan-compatible energy systems. Bioenergy from vegan waste. Anaerobic digesters can turn plant-based food waste into biogas, which can be used for electricity, heating, or vehicle fuel. This is a closed-loop energy system that reduces emissions and diverts waste from landfills. Algae-based biofuels. Microalgae grow quickly and can be cultivated on non-arable land. These organisms are rich in oils that can be refined into biodiesel, jet fuel, and even hydrogen. Because algae consume CO2 during growth, these fuels can be carbon neutral or even carbon negative. Organic and bio-based photovoltaics. Solar energy can be harvested using organic photovoltaic (OPV) materials, some of which are derived from plant compounds or bio-based dyes. These solar panels are lightweight, flexible, and suitable for building integration. Industrial inputs in plant-based chemistry. Green chemistry. Green chemistry technologies use biological processes and plant-based feedstocks to replace petrochemical processes. Enzymes and microbial reactions are used to create industrial chemicals, detergents, solvents, and coatings that are biodegradable and non-toxic. Bacterial cellulose and vegan gels. Microorganisms can be used to produce materials such as bacterial cellulose, high-strength, biodegradable substance used in packaging, wound dressings, and vegan leather. Similarly, plant-based gels like agar, carrageenan, and pectin replace animal-derived gelatin in food and pharmaceuticals. Plant-based adhesives and resins. Modern adhesives made from lignin, a natural polymer in wood, soy proteins, or starches are replacing synthetic and animal-based glues in construction, furniture, and packaging industries. Sustainable construction and building technologies. Hempcrete and plant-based insulation. Hempcrete is a biocomposite made from hemp huds and lime, used for insulating buildings. It is breathable, mold-resistant, and sequesters carbon dioxide as it cures. Other materials like mycelium insulation panels and straw bales are also used for sustainable construction. Biobricks and regenerative concrete. Biobricks can be grown using bacteria and agricultural waste. These bricks harden at room temperature, saving energy and emitting far less CO2 than traditional concrete. They are also fully biodegradable. Modular plant-based panels. Using compressed straw, bamboo, or mycelium, construction companies are developing prefabricated panels that are strong, light, and sustainable. These are used in walls, roofs, and insulation. Digital tools empowering vegan innovation. Synthetic biology and DNA programming. This field allows scientists to program microorganisms to produce animal-identical compounds, like dairy or egg proteins, using only sugar and water. These technologies are central to the production of lab-grown meat alternatives, cruelty-free cosmetics and medicines. Artificial intelligence, AI, in food and product development. AI is used to design new vegan foods and optimize taste, texture, and nutrition. Notco, for example, uses an AI platform called Giuseppe to replicate animal-based foods using only plant ingredients by analyzing molecular structures. Circular economy and waste management. To ensure long-term sustainability, waste in a vegan city must be seen as a resource. Closed-loop systems turn waste into inputs for new products or energy. Biorefineries convert agricultural and food waste into bioplastics, detergents, cosmetics, textiles, and chemical inputs, all without fossil fuels or animal derivatives. Compostable packaging made from seaweed, sugarcane, or mushroom mycelium replaces plastic and decomposes naturally. Community compost hubs transform plant-based food waste into nutrient-rich compost for urban gardens and farms. Biochar systems use controlled combustion of organic waste to create soil-enhancing carbon, which also sequesters atmospheric CO2. Vegan-compatible consumer goods and materials. All consumer goods in a vegan city, such as clothing, accessories, and home products, must be cruelty-free, biodegradable, and made from plants or fungi. Vegan leathers made from pineapple leaves, cactus, mycelium, or apple skins replace animal leather in fashion and furniture. Plant-based textiles such as hemp, bamboo, flax, and banana fibers are processed with non-toxic, animal-free methods to produce durable and breathable fabrics. Natural dyes and pigments are derived from plants and microbes, avoiding harmful synthetic chemicals and animal-based dyes. Healthcare and wellness. Medical care in a vegan city must prioritize plant-based treatments and ethical production practices. Plant-based pharmaceuticals and fungal-based medicines are developed without animal testing or animal-derived components. Green healthcare infrastructure is built using non-toxic, plant-based materials and powered by renewable energy. Hospitals and clinics serve plant-based food and avoid animal testing and procurement. AI-assisted nutrition platforms help residents optimize their diets based on plant-based nutrition tailored to individual health needs. Transportation and mobility. Sustainable, vegan-compatible transport must avoid fossil fuels, animal-derived materials, and environmental harm. Electric public transportation, including buses and trams, is powered by renewable energy and features vegan interiors made from plant-based materials. Bio-based components made from flax, hemp, or mycelium replace plastic and leather in vehicles and bicycles. Green hydrogen systems, generated from algae or solar-powered electrolysis, power heavy-duty or long-distance transportation. Bike infrastructure and pedestrian-friendly design reduce the need for cars and encourage active, low-impact mobility. Digital infrastructure and ethical technology. Technology plays a vital role in managing resources, ensuring transparency, and enabling continuous improvement. Artificial intelligence is used to optimize food production, waste processing, and energy management, reducing inefficiencies and supporting real-time adjustments. Blockchain systems ensure transparency in supply chains, guaranteeing all products are cruelty-free, organic, and ethically sourced. Educational platforms promote vegan living, sustainability, regenerative agriculture, and zero-waste practices through community learning and digital media. Regeneration and biodiversity restoration. A vegan city must be ecologically regenerative, supporting wildlife, restoring ecosystems, and enhancing the planet's life support systems. Urban rewilding projects convert parks, rooftops, and vacant lots into biodiverse habitats with native plants, pollinator-friendly flowers, and water features. Drones and seed bombing devices rapidly reforest degraded lands and introduce cover crops, native seeds, and fungi to accelerate ecosystem recovery. Aquatic restoration systems include floating wetlands, algae-based water purification, and biofilters that clean and oxygenate urban water bodies. Fungal and microbial inoculants rebuild soil life and fertility in urban farms, gardens, and green infrastructure. A fully vegan plant-based city integrates the most advanced technologies to support ethical, sustainable, and regenerative living across all systems. Food is produced through vertical farming, fermentation, and permaculture. Buildings are constructed using hemp, fungi, and bamboo. Energy comes from the sun, algae, and plant-based waste. Waste is upcycled or composted, materials are biodegradable, and biodiversity is supported through rewilding and ecosystem restoration. These technologies are not only feasible, but already in use in various pilot projects, startups, and cities around the world. When combined into a unified urban system, they form the blueprint for a city that respects all life, restores nature, and operates within the ecological boundaries of the planet. A city of this kind offers a scalable solution for a compassionate, climate-positive future.